Hello everyone. So the next program in design and analysis of algorithms lab is knapsack problem. Here you are trying to find the maximum profit you can obtain by having the whatever the capacity has been given. Okay. So now how you are going to obtain the maximum profit by considering even the weight because the capacity is be given in the as the criteria. So now we'll start with the main function. Here we have taken values in the floating because the weights and profits may come even in the decimals also. So weight of 20 means you can use minimum maximum of 20 objects, profit of 20, capacity, ratio, and temporary variable for swapping. N is for storing the number of objects and I and J is for the looping purpose. First thing is enter number of objects. You are going to enter the objects and store it in a variable called as N. Then you are going to enter the weights and profits of each object simultaneously. Make sure that first you will enter the weight of first object and profit of first object, then only you will go for the second object. Okay. So here we have used one for looping and you have scanned and stored in the weight and profit variables. Now you are going to enter the capacity of the map set. Consider I have four objects, then maybe my capacity may be around 100 or it depends upon what is the capacity is remaining. Okay, let us assume that we have given as 10. Okay, so that will be the capacity. Now again, you are going to use one for loop. Why? To find the ratio. Okay, the ratio will always be profit divided by weight. Okay, so why we are taking this ratio in order to arrange the whatever the objects are there in an order. Okay. Then again, we are going to start with first for loop, then I plus 1. Why I plus 1 we are taking? Because consider I am starting with the array number 0. So obviously I'll compare with the next element, right? So that's why here I plus 1. So now if it is less than, means my ratio is less than, so you're going to exchange everything. First you are going to exchange the ratio, then you are going to exchange the weight, and then you are going to exchange the profit. Exchanging means what you are doing here? Swapping. So you consider we have two elements, that is A and B. Okay. A is having a value called as 2 and B is having a value called as 3. So I need to exchange this. How I'm going to do? Using an extra variable that is C. The another best example is consider you have coffee here and you have tea here. I want to swap both of it. So what you will do? You will take the help of the one more cup, correct? So that's how here you are going to do with the help of this C variable, that is your temporary variable. Okay. So that's why here temp equal to ratio of J equal to I, and I equal to temp. So the same thing you are going to follow for all the three. Okay. Once you have swapped, means you have arranged all the objects with respect to the ratio, you are going to call the knapsack function, that is n, weight, profit, and capacity you are sending as the arguments. So whichever you are sending here, we call it as actual parameters, and whatever is received by the function, we call it as formal parameter. Formal means which has been copied. Okay. Here n again is the number of objects, weights, profits, and the capacity. Now here x of 20 again it's for temporary. This is nothing but the total profit you are going to get. Okay. IJ for rupee and RC is for remaining capacity. Why we need this remaining capacity means consider I am having the capacity of 10. I have fit the first object. Okay. Consider my first object weight is 2. So what is the remaining 8? So this 8 need to be carried for the next loop also. So that's why here we are keeping account of the remaining capacity. For the first time, what happens? My capacity will be full. So that's why remaining capacity equal to capacity. So what will be my vector at the beginning before I start? All will be zeros because I have not inserted any of the object yet. Okay. Now again, you are going to start with the looping. If weight of I is greater than remaining capacity, break. Let's consider my remaining capacity is 10 and my weight is only 20. I can't fit only, right? So that's why it will be break. Okay. Else, you are going to consider as 1.0 means you are putting all the particular weights into that particular capacity. You are going to add for the total profit and you are going to subtract whatever the weight you have added in the knapsack. You are going to reduce that in the remaining capacity. Now, finally, as soon as you complete it, you will check whether I is less than N. So, if not, then you are going to find the x of I divide by weight of it. Because last value means you may need only, you can fit only half of the weight or only 0.25 of the weight. So, that's why you're trying to find it again. Okay. Then finally, you're going to find the total profit. So, finally, you're going to print the total vector. Okay. So, that is your result vector, that is x values of all the objects that has been given in the question. Okay. So let us go with the output ones. So enter the number of objects. Here I have taken 3 objects. So this is my weight and this is the profit. First object weight is 20 and profit is 30. Second object weight is 25 and profit is 40. Third object weight is 10 and profit is 35. So capacity is 40. So finally the result is 1.0. So the maximum profit is 82.5. See, I told you, right? For the few objects you can fit completely because the remaining capacity will be having that value. But if you can't fit, how much percentage you can fit? You can fit only 0.25% of the last object. Okay. So this is your maps and problem. Thank you everyone.